In this lesson, we will start with a graph and then make a sine or cosine function from it, and that's called modeling. In the previous lessons, we started with an equation and we graphed it. Now we're going to have data and then find the equation. Previously, we started with this and then we would graph it. And remember that this parameter comes from the formula for period. Period is 2 pi over b. So if we wanted to find out b, we could do b equals 2 pi over p. If we had data that looked like this, and this is called periodic data, where it repeats a pattern. When you look at data, if we only had these points, we could say, well, it completes a cycle in this length of time, and that would be the period. So if you calculate, if you just look at the difference between this location and this location, or this time, then that'll give you the period. And if you know the period, then you can find b, and you can start making the equation. The distance from this line to this point is the amplitude, so now we know what a would be, and the distance from the horizontal axis to this center line is d, and that would give us the vertical shift. If we're using sine, then the horizontal shift or the phase shift will be how far this point moves away from where it would normally start. So if we think of the parent function of sine, it's starting here, but in this graph it's shifted over. So we can just look here and find what c would be. If we make a cosine model, all that changes is c is going to be the distance to or the time to get to the maximum rather than the time it takes to get here. And so that's how we could just change it to a cosine model. If we change c, a, b, and d are all found the same way. Sinusoidal means it could be a sine function or a cosine. So let's start with sine. And we already know some of the parameters. Parameters are a, b, c, and d, and the amplitude is 0.5. So we already know that a is a half. We know the formula that includes b, and we can say that b is 2 pi over p, and they gave us the period, so the period is 3 pi, and now we know that b is 2/3. Then we just have to find c and d. Well, since they didn't specify a vertical shift, we can satisfy this by having the correct period, amplitude, and making sure the point is on the line. That means we could just say, well, let D be 0, and we'll solve for C. So we have and we know an x value and a y value. So now y and x. Alright, and we will multiply both sides by 2 to cancel that. Multiply by 2. We want to do the inverse of sine. So in our next lesson we will go over the details on inverse sine, but for now it's just we'll just use the button on the calculator and we'll find inverse sine of that, inverse sine so inverse sine of radical 3 over 2 gives us pi over 3. Inverse sine of sine, they cancel and we get 2/3 pi minus c. We can multiply by 3 over 2. Cancel, we get pi over 2. Subtract pi, we get negative pi over 2. And then c is pi over 2. So the function will be 1/2 sine 2/3 x minus pi over 2. That is one of many functions that will satisfy what they gave us. Okay, same type of question. The period is 4 pi. Amplitude is 2, and the point is pi, comma 2. Pause the video and try that problem. So we know the amplitude. We can solve for b. That's 2 pi over p, 2 pi over 4 pi. So we get 1/2. And we're left to find c using x and y. But we'll just let d equal 0 again, just because we have two variables, and that would be difficult to solve for two variables. Well, impossible to solve for two variables with what we have. All right. So we have that, and now we have a y value of 2 and an x value of pi. Let's divide by 2. We will do inverse sine. So inverse sine of 1 is pi over 2. Inverse sine, here we get that. All right. Multiply both sides by 2, and we get pi. Subtract pi, and we get 0, so c is 0, and that means the function is 2 sine 1/2 x. C is 0. Okay, so that's one type of problem that we see with this, and there's another type of problem. So we have data, and that's all we have. They don't tell us anything else. So here we have to be careful with what we choose, and when we find a model, it might not be the best model. So for this example, we're just going to go through the mechanics, but we can always, if we really wanted to refine the model, we might have to do it several times and keep testing the parameters that we find. So here we have temperatures for the months of the year, and let's start by graphing this, and then we can just look for the distances on the graph to solve for the parameters of the equation. So the maximum temperature is 66. Let's make sure we have enough room for that. So 1 will be January, we go to 41. 2, we go to 44. 3, 47. Then we go to 50. And 5, we go to 56. At 6, we go to 61. 7, we go to 65. Then we go to 66. Back down to 61. 54. Down to 46. And 42. So this looks, or if we made a cosine graph for this, it's going to be a little off. I think it's easier to do cosine just because it's easier to see a maximum rather than trying to figure out where the midline would be here. You can just look for a maximum. All right, so since if this is a minimum and that's a minimum, then it's not symmetric. So we might want to not use the highest point. Why don't we use that point instead of that point as the maximum, just so that if this is the maximum, our graph might curve down here instead of going up there. So let's just use this for now as the maximum, and that occurs at 7. And now let's say there's the maximum we're going to use, and let's use that as the minimum. So if we look at that distance, here are some lengths that we need to use. This is not a complete cycle. The complete cycle goes from here to here. So if we could use that as the period, or we can just say that this is half a period. We also have this as being C. If that is going to be the maximum, it got shifted 7 away from the y-axis. So there's C. This is going to help us find B. If we find the mean of these two values, that can give us D. So we're going to take the 65. D is going to be 65 plus 41. 65 plus 41 will give us the mean of those two. 65 plus 41 divided by 2. And we also can find this is going to be A, and so that's going to be halfway between 65 and 41, so that's going to be 65 minus 41 over 2. And then we're just going to fill in the numbers, so y equals A cosine B, x minus C plus D. And we need to find 65, this will be 12, and that is 53. We have to solve for B. So if there is, we know that from 1 to 7, so that's 6. We know half of P is 6, so P is 12. All right, and we have period is B is 2 pi over P, 2 pi over 12, and that's pi over 6. So the amplitude is 12. B is pi over 6. C is 7. And D is 53. Here's another common application for sinusoidal models, and that is modeling the tide height. So here is some, here are times, and I originally had days, but it must be hours. And here are the tide heights, represent the tide heights using sinusoidal function. So graph the data and find out the maximum, and just look at the dimensions of the graph to find the parameters. Pause the video and try that one. And we have to go all the way to 30. So at 1, 25.9. We can change these. Now let's break the graph, and we'll start at 20. So 20 up to 28. Let's go 20, 24, 28, and this means the graph is broken. It's not starting at 0. The axis, there's a break in the axis. So at 1, 25.9, 25.9, 25.1. No, it's out there. And then we're going to go at 9. We go to 23.5, 10, 23.3, 16, 27, 17, go to 28, 18, back down to 27.9, 20 is at 26, 25, 24.2, 26 goes to 24.3, 29 is 25, 30 is 25.5. So going up, doesn't come all the way back down to that. So here's where maybe you have to think, well, I'm going to make this, the model will go a little lower than this and a little higher than that. You can modify it, refine it how you want. For right now, why don't we just look at the high point and the low point. So with these, we can make a model. And the low point is at 10, and the high point is at 17. And we know that that is half of a cycle, so that's half of the period. And this is 17:28, and this one is 10:23. So we need to find this length is going to be the amplitude, and it is 28 minus 23 divided by 2. Amplitude is 28 minus 23 divided by 2, and that's going to be 5 over 2. So we know that that's 5 over 2 cosine. Let's look for half the period is 17 minus 10, so that's going to be 7, so the period is 14. And we have period is 2 pi over b. B is 2 pi over p. So the period is 14, and we'll have 2 pi over 14, or pi over 7 for b. For a cosine function, the horizontal shift can just be the x value of the maximum, so 17. And then the vertical shift is the mean of the y values, 28 and 23. 28 plus 23 over 2 25.5. All right, and then to evaluate the model or test the model, we could put all of these x values into this and see how the y values of the model compare to the y values of the data. And we'll stop there.